probably reconnect it before we go into it, so it'll just take a second. So just let me know when you're ready. Yeah, to show the app. I can take. Yeah, I'll take this slide because I did before.
Yeah. I can just get back to stuff.
Oh my gosh, the camera's weird. There we go. We might wait a couple. I don't know.
You want to wait like another? Let's give it another like 3 minutes for people to like file in. You guys want to get some water?
This is weird.
Yeah.
Some yoga stretches.
Yeah. Senior power attorney announcements.
That looks really good.
Yeah,
There is
we
a
have one.
happy hour next Tuesday.
Yeah, we can announce that. That email should be sent out to you too.
Did you want to make the announcement?
Yeah.
Yeah.
Happy hours at what's it called?
The rec.
Yeah, that's it.
And
There's also a Scala meetup tonight about Scala Check. So if you're interested, come.
We can also like recap with the announcement.
as always, sign up for
at the
conferences.
end.
Channeling Elena right now, so do that. Secondly, there is a small Toastmasters next Tuesday that all of us will miss. We're telling them that, reminding them that, hey, maybe you have more people showing up, or 50 more people trying to canvas, but everyone will be gone. So maybe someone will come from that to the happy hour and chat with people there. So I know they've been trying to grow their ranks, and it's just about trying to talk better in front of people. I know we all are terrible at that.
How easy.
It's not hard.
Yeah.
Trick is if there's anything else. Anyone else yeah, there's nothing. They never. Yeah. But I know. They just want to go now.
Do any new items that are
That I'm not sure of.
that would be right.
Yeah, you got this one out of the park. How did that record it?
Is it? Yeah. It's good. You're famous, man.
No, still in it. Still in it.
Alright, I'm gonna just figure it out. Alright, guys, thanks for coming out. We're gonna have 2 speakers today. We're gonna have John and Pat talking a little bit about Google Cardboard and some reactive programming. Hope everybody likes it. It's also being recorded, so you can catch this all again later and really like it. So let's give it up for these guys, yeah?
Okay, so yeah, first off, we're just gonna just recap this virtual reality app we built for an event at the BMW Championship earlier this year, or last year, September of last year. So yeah, we'll just kind of walk through it. So these are slides from, I don't know, the Project Spotlight call that happened a couple weeks ago, so we didn't put anything together here, just kind of reusing some of the material. So the BMW Championship, in case you guys don't know, it's a golf tournament. It's the 3rd leg of the FedEx Cup playoffs. Top 70 players on the PGA Tour make it there, and then it gets cut to 30 to go forward. It's held, so it rotates between Conway Farms, which is in the north side suburbs, and a couple other locations. So this year is at Conway Farms. In Slalom, the last couple of years, the Hair has had a suite on the 17th hole. So if I go there, you can kind of see this is actually this is a screen cap from a YouTube video showing this golfer right here hitting his second shot from the stands. That's Fabian Gomez. He actually put this shot 6 feet from the hole, which is kind of impressive. But the reason I'm showing this is this is what the stands look like next to this hole, and you can kind of slalom people, slalom shirts. So that's kind of the suite that they were in. And so the idea was that we'd invite a bunch of clients to this suite. We can kind of show off what we can do. We can give away a bunch of cool stuff, some swag, kind of good slalom marketing stuff there. So that was kind of the event. So we were kind of the challenge. The challenge was we wanted to bring together a bunch of different teams in slalom, create something cool, kind of highlight some of our innovative offerings, promote our thought leadership, think out of the box, all that good stuff. So we ended up doing. We worked with, obviously, Patrick and I from the engineering team. We had the INMA team and Innovation and Insights team and the Digital Solutions team. We kind of worked together to create a Google Cardboard app. So we kind of decided to use Google Cardboard. There's a bunch of restrictions on what you can bring to a PGA Tour event, so we didn't want to kind of have to deal with any of that. Computer stuff like that. So the idea was all we would need is this, a Google Cardboard, and a phone, in this case Android, and we could kind of put together a cool experience. Just kind of talking a little about the app. So the idea was, so this is the 17th hole. It's a 230-yard par 3. And all day before the event, before they actually built out a bunch of the grandstands, they had some of them kind of go in here. But all the clients are going to be in this suite, kind of just looking at the green of this hole. So wouldn't it be cool to see what it would look like from the tee? What would it be look like actually to be on the green and maybe to be in front of the green? And as you can see in like this just standard image, you still can't really tell everything that's going on. If we kind of click, you can kind of see that. If you're able to look behind you, there's actually a huge grandstand behind you, also to kind of give a stadium-like appearance. So it was decided that we should highlight this. So what we ended up doing is we ended up creating a bunch of different photospheres, and then the user could click through this app and go to these locations. So with the help of John Busby and his camera and skills, we were able to create a couple different locations that when we walk through the app you'll see later. This just kind of highlights the process of taking a bunch of different images, stitching them together. I think he said he took like 90 photos to create a single one of these images. So it was a process. He would probably love to talk about it if you want to hit him up on that. So that's the one. So that's one thing. So now we kind of have experience, but we also wanted to kind of add another part to this of, okay, cool, you can kind of create some cool images, and I think that's cool enough. But we also want to kind of show what we can do as far as kind of seeing insights into the tournament. So this is where the IMNA team kind of came in. They put together a bunch of these stats that kind of showed a bunch of different things, such as just stroke results, kind of how hard the hole was, how much money people gained or lost based on performance of the hole, stuff like that. So the idea was like we could have this handout on a table that looks cool, but why don't we try to incorporate this into the app? And obviously not this whole image into the app. That'd be really difficult to read and obnoxious. So as you'll see later when we show the app, we have different kind of trigger points that you could look at, and then something will pop up at you and show these different things. Patrick?
Sure. So from the engineering standpoint, we had, when we started, we had about, 3 or 4 months to get this done?
Yeah,
and I think
about right.
That's on the far side. So we said, hey, okay, 3D app, 3D experience, let's use Unity 3D. So we started started messing with it, and we ate shit real fast. We reached out to M-Level for help, and they just kind of said, like, for what you're trying to do, this is actually overkill. So what we did instead is we found a 3D engine for Android that was already, it's much simpler, and it was open source. So with only probably a month left at this point, we started.
That's
Yeah, that's pretending we didn't procrastinate at that month at all. We just started grabbing features from the IMNA team and from product design, and whatever we could implement, that's great new feature. This is what we could do for the app. And so the app came together kind of in this just breakneck cycle where we can do something, great, put it in. We can do something else. Oh, now we have sound. Oh, now we have motion, and it's perfect. Skyboxes are great, no more memory leaks. So it just became this really swift, really hardened app. And as we got towards the end of it, it kind of became more of an abstract library where we can just start switching out assets. So we can ditch the skyboxes, we can ditch the points of interest, and if someone else has another 3D experience they want to create, they can sort of use this framework that we made to easily populate it with new images and new info.
Yeah, so as Patrick said, we did end up developing an app just on the Android platform using the Cardboard SDK, an open source 3D library. It can be really easily reskinned to do different experiences. I believe they're currently doing another golf related thing in Dallas using this app. I think Busby's talked through to a couple different clients about trying to do something similar, such as maybe touring their new office or different experiences like that. So Patrick's going to try to load it up on his phone. Unfortunately, the phones we used are at other offices for this, so we can't kind of demonstrate it on Cardboard, but we're going to try to do it this way real quick. It is out there in our Bitbucket account. I should make it public to the team, but so this is what it would look like. Obviously, when you have the goggles on, it's one image. There's this sound that they wanted to play the whole time. It's just a looping audio. So this is what it would look like if you were standing on the green at Conway Farms. Like I said, these pictures were taken. It's a private country club, so we got access to it before the tournament. So as you could see, they still have this stuff of okay, don't actually walk on the tee box and ruin this for him. As you can see when he looks at that Slalom logo, oh, here's a interesting stat. Most people get par on this hole. And whatnot.
And that was driven more by the data team. That's what they wanted to offer to the clients, was just the ability to look at a hot spot, and they ran the numbers from golf history previously, so they could develop all kinds of interesting statistical analysis, like how much this hole either cost somebody if they did poorly, how much this hole ended up earning them money if they got ahead.
Or this one just shows the difficulty. I think this hole was the fourth most difficult on the course, and I think this is an image from in front of the green. So this is if you put your shot real short, you kind of see the box and whatnot. And one of the challenges too. This doesn't actually use any. All these assets are already in the app. It doesn't pull data or anything from anywhere. Mainly because. Internet connectivity at events like this is really, really crappy. So we didn't want to be in front of clients and look at our app and then nothing's loading or anything like that. So yeah. And then this last scene is just a simple scene of what it would look like on the green. So this just kind of shows who won it in 2013, the last time it was there, and again more stats.
Right, and you're in or out board, and that just kind of reaches out and touches the screen. So by just touching the screen, that's how we cycle between our scenes. Each scene has points of interest, and I think there's just a couple interesting just technical decisions we made along the way to get everything operating. But in the end, it actually supports quite a number of scenes, quite a number of locations of interest, and it's all swappable.
Yep. So yeah, and I think like I said, there's definitely been some interest. I know BuzzFeed's been out and about trying to get interest on their app, and so that's kind of cool. Any questions before Patrick gets into Reactive?
What's up?
What was the name of the 3D engine you used?
It's some really.
I couldn't pronounce it if I wanted to. But it's like Rajwali.
Yeah.
It's
right.
Definitely a grants project, like senior capstone from India. So it's like we found it and we just thought the thing is going to work. And for all of our purposes, it did. It was great at displaying a skybox. It was great at pasting images on some like primitive 3D type like frames or objects, and then just doing like some really easy animation transitions to get the boxes kind of oscillating to grab your attention. So it really worked out well, and it's I have nothing against it. I think if we were going to go back and had time, we'd want to do it in Unity 3D, just because then we could support more devices than Android. But I think under our time constraints, it was a great find on our part.
Yeah, definitely. Yeah, worked out real well, that's for sure.
Did you guys create the skybox out of the photosphere itself, or was there anything sort of specific process for that? Like photospheres were used to generate from BuzzBee, went there alone, did all that stuff, gave you all the source files from photospheres, and then you generated the skyboxes off of that?
So there, essentially there was a 3D object in the library that you could then just paint on.
Oh,
That- yeah.
Chuck it in there?
Yeah, so
Oh,
you
cool.
essentially could just throw it in there. I forget the exact element name. But yeah, it was an element name that you could swap in, got different images for it. So yeah, that, like I said, in the end, that library actually handled a lot of the stuff for us, which was nice.
Right. I believe it was basically like a big, we set the camera in the center of the scene, and then we had a big sphere around us, and the inside of it was painted. And for some reason, painting the inside of something in Unity 3D was just insanely hard. Like you had to paint the outside and then transform it and basically like turn it inside out, and I just was going cross-eyed trying to figure it out.
Could
all
you just
that
use
math.
Could you just use the skybox in Unity 3D, or no?
No.
It didn't work out?
Yeah,
Okay, weird.
that's one of the reasons we reached out to that level team, because we were like, we got to be missing something here. But they said, yeah, it's not really.
Yeah, the skybox is an actual box.
Yeah.
And so, that box. So.
I think if we were going to actually try to like model the whole in 3, then Unity would have been, by far the best chance, but that would have been pretty difficult to do in our time.
Yep.
So I know they have those like VR camera rigs that you can buy. If you had enough, like a good Wi-Fi network, would it be possible to do a live stream?
Potentially, it'd be something interesting to look into.
It's definitely been done. Like a lot of the showcase apps for Cardboard was, I think they had like from the center of an Elton John concert or something like that. So you can do live video, but yeah, you need one of those nice rigs. We found like because you're on a phone, memory becomes a big constraint real fast. Like the Skybox photos that BuzzBee had sent me originally were just super high res, and they were 50 megs as a JPEG, but then when you unpack that into a bitmap, because everything that gets buffered to the screen becomes a bitmap, it was sitting like 3 gigs of pixel data sitting in memory, and it was bad news.
Yeah, I believe BuzzBee actually picked up two of those cameras that can record 3D and tried it out, and yeah, you can just upload those to YouTube now, and you can actually play them through on a cardboard and look at them. But like you said, it really didn't offer us much as far as the experience. So that's why we kind of went with this approach, especially when you want to incorporate all the analytics stuff into it.
And that's because YouTube has had 3D support for like a year now.
Yeah. So you can watch any of those YouTube videos on the cardboard that are 3D supported.
So is your content just fixed to a single central point, or can you like walk around the scene?
Right now, it's just actually you're fixed in the scene, so you're just looking in the scene.
Did you guys attempt to implement being able to walk around?
That was kind of our post MVP. If we kind of got to that point,
Right, that was one of the ideas that it couldn't stick to the wall with the time we had.
Yeah.
We also did an interesting thing. Our points, so they appear are locations of interest. How they know to appear is actually, we're not using the API that came with the library that says is looking at, because it was huge. Like if your little box was in the corner of the screen, even if it wasn't in focus, it would pop up. It was so sensitive. So what we're doing instead is kind of a hack that I'm not proud of, kind of proud of, is that each one is that it's actually like the point is triggered by the pitch and the yaw of the camera. So if I put a box up here, then its Y is like 30 degrees and its like pitch is like, okay, I need to turn around to see it. So that's how, if it's within about 5% tolerance of the pitch and yaw, then that's what's making it like appear. And if it fades out of that, then it does a fade out transition. So it would actually be, we would have to totally ditch that hack if we had people moving around.
Any other questions? Yeah. If you haven't had a chance yet, you can actually download just the plain Google Cardboard app on an iPhone and Android phone. And use one of these things to take it out. It's actually pretty cool what they have in just their built-in app. And I think we're gonna see if we can, I don't know, at one of the Fridays at 4s, get some phones and have this set up so that if you guys want to actually take a look at it and see what the experience is like, we can do that. Sounds good.
Cool. That's about it from the BMW Championship.
Quick question.
Sure.
Yeah.
The songbird you had looped in the audio sounded like a brown-capped rosy finch, which is not endemic to the Midwest. Did you beta test this bird?
Unfortunately, we didn't. Next time we'll reach out to you. Yeah, no, that was. I forget who actually put that together. They recorded the golf. Someone actually in Slalom put that whole thing.
Oh, that was actual audio?
Yeah, that was
right.
someone in Slalom did a golf club. The sound of the golf club contacting the ball, the clapping, and the bird.
John caught me. All right.
So.
Yeah, they really like sort of they like Chewbacca the golf experience by like taking like 4 different golf audio scenes and putting them together. So it is just like the subliminal sounds of golf minus the swearing.
Yeah.
All right, thanks, John. All right, this is Reactive Programming featuring RxJava and Android. So what is Reactive Programming? If you ask a bunch of different people from a bunch of different programming languages, you're going to get a different answer every time. If you ask somebody from DevOps, they're going to tell you about scalable systems, they're going to tell you about fault tolerance, resiliency. But what I'm going to go with is I'm going to go with programming that instead of like object-oriented programming where everything is an object, this is everything is an asynchronous stream of data. So why streams? It's kind of important in the mobile space to treat a lot of your data as streams if you think of where they're coming from. If you think of an app like Facebook or Twitter, you're getting data all the time. It's constantly refreshing. It expires, it caches, it gets released from the cache. It's never static. You're never really reaching to this dictionary of data. It comes and goes. There's kind of a time element to it. And the second part of that is, well, why asynchronous streams? And the reason is that scalable systems tend to talk to each other in messages. Things can happen when actors in a system talk to each other, and these messages, they can time out, they can error, there's a delay, they can come back and the client's not paying attention anymore. So with reactive programming, we want to kind of build in all of these considerations to the system. Also on mobile, there's a very practical concern for asynchronous in that almost any data access, except the most absolute trivial in-memory access, if it takes too long, the app is just going to crash. The OS has permission to kill your app if you're blocking the wrong thread. So on an Android app especially, almost everything we do to get data has some sort of async wrapper put around it. And very selfishly, I got interested in reactive programming because I feel that Android's async wrappers all suck. The other thing that you get when you start thinking about async is that it simplifies your API. Does this mic sound all right? Am I popping it all?
No, you're
Good.
fine.
Okay, good. Sounds weird. All right, so this is a client anti-pattern that I see all the time, and I've done this too, and I've learned the errors of my ways. So you're in your page of your program, and then you need to get some data. So you go out to your service, and you check its cache. And you say, oh, okay, there's data in the cache. I'm going to open up this workflow where I'm just going to do stuff with that data. That's not there. If there's no cache, then I'm going to say, okay, I'm going to do this weird UX thing that wasn't there before. I'm going to show a wait spinner. I'm going to go get remote data from a remote service call, and then it's going to hit a callback. I'm going to do my thing, and then I'm going to take the UX away. This is complex, and it's needlessly complex, because we now have to support both a synchronous API and an asynchronous API. The clients are being too clever. So if you can get rid of all of your synchronous calls on the clients, what does it do? You reduce all of that boilerplate. You get rid of 90% of the code on the previous page. It's all gone. You just treat one code path the same way. It's less to test. It's less errors. And it makes your API smaller. Overall, it just reduces complexity. So the other main point of reactive programming is based on the observer pattern. Everything is an observable. So the general pattern that you follow in reactive is you have a data source. That data source is an observable. It performs all of your I/O, all of your logic, and it gets your data from point A to point B. When the data is finished with its processing, it calls the client. The client is the subscriber. And the subscriber unsubscribes when it's done listening after it performs its tasks. So also in Rx libraries, beyond the subscriber pattern, there's a lot of other kind of considerations just beyond sort of implementing your own subscriber observer type library. So some of those concerns are, well, when is it time to go ask for new data? What if we need to get data from multiple sources at the same time? What if we don't want any more data? What happens if a remote source screws up? What if there's an error? How do you handle it gracefully? How can we reuse common components? And how do we handle threading? And that's where the reactive libraries come into play. So I'm looking at Carl right now. I will give .NET credit. .NET is the first platform who really pioneered reactive programming with reactive extensions. Good job, guys. You got one. So on their heels, though, is Netflix. Huh. Who knew the world's most premier streaming company was kind of cool with a programming paradigm dealing in 100% streaming objects? They introduced more observable type methods to the platform, and then they created all these higher order convenience functions that are just so powerful if you come from, say, Java 1.7. Finally, RxJava, they had this under the Netflix flag, and they kind of open sourced it and contributed to another organization, ReactiveX. And at this present time, you can basically get an Rx library in just about every language you want. Swift, Cocoa, JavaScript has one. So you can really program in this paradigm. So what do these libraries provide? They provide a implementation of more of the theoretical foundations of reactive programming. They have the utilities to create observables from regular data sources and to create subscribers to those observables. They also handle concurrency, error handling, and manipulating those subscriptions, so you can turn them on and off if you no longer care about the data. And finally, last but not least, are the operators. The operators are all the utility methods that you can perform on an observable stream. There are I think a lot, if you add lambdas or any kind of like dynamic programming, you're probably not going to be as if you're stuck in Java 1.7, like the Android platform is, you're gonna, it hurts. It hurts how cool some of these functions are. But before we get to those functions, there's a couple just fundamentals that we need to know, and it's what does a subscriber do? So in terms of an Android app, the subscriber is usually the UX. It's the client layer of the app. And a subscriber is an interface that has three methods: onNext, onComplete, and onAir. Creating observables, creating observables from a data stream. There's a set of that just take a normal object like a list function, or anything really, and it just creates an observable interface for that allows you to subscribe. This would be a simple subscriber. So all this guy is doing is that every time an observable sort of notifies a subscriber that, hey, I've got new data for you, it's going to hit that onNext method, and it's just going to print it out. So this would be a subscriber that's looking for a string observable. It's just going to be constantly emitting strings. When the observable is all done, giving out all of its data, it's going to call this onCompleted method to signal that you can go on and do your thing. And finally, it's going to also give you this onAir method that if at any point within the observable, any logic that happened that was encapsulated by it, it's just going to say, hey, something bad happened. I need to stop sending you data. So this is my first example of creating an observable from a data source. So this real fast, this is what I call Pat script. Room 7, 1.8, the IDE is PowerPoint, and it always compiles. So in Pat script, we're creating a list, just a straight plain, and this observable just takes the object and it just emits one thing. So in this case, it's just kicking back the string in its entirety. So the subscriber that we saw earlier, it's going to have its callback fired once. So it's going to say, oh, next is here. And it's just going to give you the list of strings, 2 strings. And then its complete method also just fires up a message that says, hey, I'm all done. The next observable creation method is from. And this one actually reaches into your list, and it creates an observable for every item in there. So the same thing, observable from name list, subscribe to it, except this time the subscriber, its callback, hey, next, is going to get pinged 3 times. It's going to give you 3 separate pieces of data, and then say, hey, I'm all done. When talking about reactive programming, there's kind of this awesome visualization tool that people created called marble diagrams. This is the marble diagram from the from operator that I just showed you. And so this right here, this kind of means that we took this list of objects, we applied the observable from to it, and what we get here, this is the stream symbol. So it's all of these data objects are going to get emitted to the subscriber. Operators. These are the methods that transform the emitted items before delivering them to a subscriber. The most basic one is a map. And I think if you've worked in Ruby or JS or anything like that, you know what a map does. It takes your collection of items, and for each item, it applies some arbitrary function to it. So this one, for example, you have 3 numbers in an observable. It's just multiplying it by 10, and before it delivers it to the subscriber, it changes the result. How this gets useful is that you can chain these operators to create multiple effects. So in this example, we're grabbing all of our strings, taking them to lowercase, and then doing one more transformation where we strip everything out of the first letter, and then so we're emitting ABC. We also probably emit Alpha at the end of that too. So now this is my operator roadshow where I have selected artisanally handcrafted operators for your delight. Some of the cooler ones are all the filter operators, where you can take your list and you're only going to return the items that meet some sort of criteria. So up top in this case, that's another creation operator, is that range. You can just arbitrarily put a range in there and it's going to create, start emitting like from 1 to 5. And then it's going to filter out all the odd ones. Down at the bottom, that's just one that's taking a bunch of numbers and only giving you the ones that are greater than 10. Distinct is useful. It gets rid of all the duplicates in a set. Real easy to use, just one word. You can pass in kind of custom logic to determine what's distinct. So it gives you a bit of flexibility. This is just the base case. Deep bounce is a really interesting one. Deep bounce comes from EE. I think there are people here who can explain it better than I can. But the gist of it is, if you have an observable that's really bursty, like a click handler, where it's like someone's tapping or someone's typing, this is going to let that observable, that data stream, do its thing. And then when it stops for an allotted amount of time, it's only going to give you the last value that was put out. So what I've seen this used for, which is very cool, is on the UI. So think about a type ahead, like a search, where you start typing, you wait a second, and then it gives you like a list of results. This is like the easiest way to create that, because if I start typing aardvark, and if you don't want to go fire off like a request on every letter in aardvark, you just want to start typing, and maybe if you pause at AARD for a second, then it's going to send out a request for that. Then if you keep typing, get the whole word in, it's going to send out maybe 2 requests instead of 1 request for every letter. So people that actually use this, they create streams out of their UI layer. They just kind of bind an observable to the click handlers in their app. So it can go the other way too. So rather than coming from a data source on the internet, you're collecting all of your human user input and then filtering that and then creating calls based on it. And so last but not least, this is where things start to get super awesome. The zip operator. And so if you look at this marble diagram, you're going to notice that there are 2 streams going on right here. So 2 observables, 2 different async sources of data. What the zip does is that for every time each one of those emits something, it waits until you get data from each one, and then it applies a function to it, and it binds those 2 data sources together as one. So what's the implications of this? It means you can combine remote service calls. You can, so in Android, we actually have a RESTful library that returns observables. It has RxJava built into it. So something like we're on the Charter app right now, and it's all about dealing with movies, dealing with streaming, very, very Netflixy in its use cases, and it's also based on a lot of microservices. So what happens is we have kind of objects that come back to us. Like in this case, we have a movie, and we get a movie, but we don't get like a fully populated list of objects. We get like this skeleton of a movie that's kind of useful for displaying like partially for our UX, because they don't want to give us whole like big just manually chain a lot of calls together, a iterated object. Using the zip operator, we can do RESTful services that are combined, and we don't even have to think about it. So in this case, this is definitely a case. If we have the ID of a movie that we want, we get our movie object, and at the same time, we go out to another microservice and grab all the images related to that movie, and then we can just apply any arbitrary function to fully populate our object. And then our UX doesn't know anything whatsoever about what happened. In essence, we've kind of created this asynchronous view model that different pages of the app need different views of the objects. We can get it lazily right on time. So that's pretty cool. What's up?
Can you go back?
Yes.
Cases similar to this where you have your first call gets you that skeleton, but that first inside of that skeleton is like a URL you would need to grab the image. How would that work here?
You're getting ahead of me, but that's awesome. So that's easy. Combining async calls is simple if they're not chained, then. But what if the second call needs data from the first? Well, what we could do is we could wait till that first call comes back to the subscriber. We could get all our data, and we could pull out. We could do that again. Like then we could make our call again with that second set of data. But that sucks, and it's not the reactive way of doing things. Chaining async tasks, and the problem is once you get that stream back, it comes back with POJOs, and you lose all of those operators that we've just grown to know and love. And then we have to do separate operations. We have to create separate subscriptions. It's a bit clutchy. That's where flat map comes in. Flat map, and this is directly from the site, is a flat map will transform the items emitted by an observable into observables, then flatten the emissions from those into a single observable, which, if you ask me, makes no sense whatsoever. It's actually, flat map is probably, it's one of the most difficult functions to kind of wrap your head around. And really awful because I had to give this talk right now and I just couldn't wrap my head around it until I read Netflix. Actually, they came out with presenting reactive streams about a year ago at a big Java conference, and like one of their microservice directors, he's going into his code, he's going into his functions, he gets to a flat map and he's like, do not feel bad if you don't understand flat map, because it is extremely difficult concept. What I started trying to like just really model what I was making off of the Netflix example. So I was trying to create an API like theirs, and what they said is that this is kind of like the old, this is your app you're going to have in an app for getting data. Netflix was saying, it's like, okay, well, step one, if you want to do reactive programming, you should have a reactive API where rather than just returning the data you want, you're returning it wrapped in observables. And so that case you were asking for, where the second set of data relies on the first, is that you just sort of have this nested method where So this movie API, get movies by genre, that would be an asynchronous call. It can take however long, but when it comes back, it creates this callback, and what it does is it comes back with this list of movies, an observable list of movies. So the first thing we do is that we take that observable list and we make every movie in it an observable. And then we feed that into another map, and that says, okay, for every movie that we have, when it comes back, go put it into our Get Movie Images API. And then this is also asynchronous. So when that comes back, it's going to give you a list of images for every movie. And then we can do like the meat of that method again, where we're just finally, after we have all of this data kind of like flowing together, you can just start populating it and doing what you need to do. And at the very end, you can kind of take all of that. You can either pop it out one at a time if you want and have your client just perform its callback every time fully populated movie comes in. Or this to-list method right there, it just waits until everything is done and puts all of those back into a list and feeds it to your client. So that's super confusing, and it makes everybody feel dumb. So let's feel smart again. Error handling. Error handling with subscriptions is super easy. Remember that each subscriber, in addition to its onNext, also has an onAir and onComplete method. If any exceptions get thrown within any operator or like any data call, if anything bad goes wrong at all and you're in observable land, it just says, nah, I'm done, screw it. And it pops out the error method, and you can kind of deal with whatever error came back. And you can do things like you could try again. You can do like an exponential decay where you try again, and then you try again maybe 2 seconds later. You try again 4 seconds later, then you try again 8 seconds later, just so you're not like slamming on the network. And the one other little piece of minutiae is that onCompleted method that won't be called at all. So I wanted to create a little demo app to try and exercise some of these operators, and just to make sure that all that flat map nonsense would actually work. And what I discovered is, well, why create an app if I can just create a dozen unit tests? Putting things in observables is extremely testable, because really you're just kind of composing this big chain of logic. So each piece of that chain can be unit tested, and then you can actually like perform full integration tests on these named chains of operations, and it's like testing an entire workflow at the same time. Like you can just test your entire login workflow from start to finish, and you can get a subscriber at the end that says, hey, everything worked, hey, all my data's here. And same thing, you can also performance test this. If you have this huge chain of logic that you're composing through all of the methods in your app, you can kind of have an observable that whenever it starts, whenever somebody subscribes to it, it starts a timer. At the end, it'll just kind of collect the entire difference of how long this operation took. So it just gives you an opportunity to really, really test. And furthermore, it pushes so much of that like method composition, like going from data source A and data source B, it gets rid of so many of those like interactions and just makes it straightforward that so much more of your app kind of falls below this watermark of testing. It just becomes trivially easy. Oh, and threading. Threading is also super easy. This is just a quick example. So if you had a database that you wrapped in an observable, you can run a query on it. You can do the subscribe on operator, you put any arbitrary thread in there. So you're telling this database, go do your stuff on this worker thread or this thread pool or this, do it in the place to do work. And then when it comes back with data, take care of all of that on the UI thread or wherever it needs to get handled. This is specific to Android, but you can't really modify any of the UI stuff unless you're on the main thread. You're going to throw exceptions. So it's like any observable you want to make in the Android ecosystem, you can just base off some subclass that puts all of your threading in the right place, and you never have to worry about it again. And so real fast, I have a bit of time left. I just wanted to show you how easy it is to test this observable structure. So for this, I kind of created this mock movie API. It's just got a static list of movies and a bunch of blank images for each movie, and 2 methods. It's got this get movie images, which requires a movie, and it's got a get movies by genre, and each movie has a genre. And so immediately you can see, rather than pass back the list, I'm going to bind an observable to that list of images I just created up here, and I'm going to apply a filter to it. And so each image has a movie ID with it. This call right here just says, hey, any movie in my list that matches my movie ID, great, give me that. So this is kind of just the mocked service. And same down here, each movie has a genre. We're just running a filter method on it. Just grab me any movie in my movies list that has the genre. And then I'm exercising all of this through unit tests. And so how do you test this? Well, RxJava comes with this cool subscriber out of the box called a test subscriber. The test subscriber, you declare the stuff it's expecting, and then I'm running my API, and then subscribing it with the test subscriber, and then I can assert a couple things. I can assert no errors happened, and then I can assert that there are 2 movies or 2 images that came back from this call based on the movie I gave it. There's one other way to test that goes kind of around the test subscriber you get out of the box. You can take this asynchronous observable and you can call this toBlocking method. And what that does, it gives you another type of observable called a blocking observer. And this falls down to synchronous. So then all you can do is, in this case, it's giving me that synchronous observable. It's giving me the first item off it, and then I'm just testing the size against, hey, I'm getting 2 movies back in this call, which is expected. If you don't do the toBlocking method, it's just going to fall through the test, and it's not actually going to test the assert. So I'm putting my money where my mouth is. I'm making sure these tests are running. Here's that zip example. So in this case, if we know the data beforehand, I'm calling both my API methods, and then when they come back, I'm putting them in a function, and all that function does is kind of just merges the images into the movies. So very simple, really easy way to combine multiple API calls. Oh, so this is a cool one. This is what happens when there's an error. Same thing, it's the zip method above, except this one is just going to, so this is just going to go and reach out and grab the 100th movie in my list. There isn't one, so it's going to give you an index out of bounds exception. So we run this, and then what we can assert at the end is that my subscriber, let's get a list of all the errors that happened in that subscriber, and we're going to check its size. So, yep, there was an error. So that test is true. Same thing, we're going to get the onCompleted events, and we're going to check that 0, which is also true because if there's an error in your subscriber, then it's not going to hit that onComplete, and its onComplete count isn't going to go up. It's also interesting to note that if you have unchecked errors within the subscriber, it's not, or within the observer, it's not going to blow up your app. You could have any error, null pointer exception, whatever, for better or worse, because sometimes if you have those catastrophic errors, you want to fail fast and hard so you catch it. But you can also do some more user-friendly things, like on error, just put up a message that says, hey, something went wrong. So better experience versus more reliable app in the long run. Finally, here is that flat map monster. I super hate Java 1.7, so it looks much uglier than it does in PatScript. But here we see, basically I tried to annotate it as much as possible. We're getting our movies. When we get that movie list, we turn that list into a bunch of observables. For every movie in those observables that come in, we call our second API, let's get the images. When we get the images, we populate the movie. And then finally, we wait till all of those are done. We turn it into a list because our client asked for a list. They didn't want a bunch of callbacks happening over and over. And then, I guess what I didn't mention is that what kicks off an observable? Observables get started as soon as something subscribes to it by default. There's a bunch of other methods that can kind of control when an observable is going to emit something. But right out of the box is nothing happens until it has a subscriber. And I'll just run all of the tests because I like seeing green. And again, we have so much logic of this app completely tested, completely ready to go. We didn't have to create a UI to exercise it. It's under test, which is kind of awesome. So, what's up, man?
So for somebody who's like me, I'm more familiar with how Event Bus works. How does this relate to being able to have a subscriber subscribe to an observable when they're not within the same class, not within the same activity lifecycle, for example, or fragment lifecycle?
So reactive, and so we use an event bus on our charter app. And after kind of looking at reactive, we've sort of found that reactive deprecates event buses. Like you can still have that model. I've seen people create Rx event buses if they like wrapping their head around it that way. But the way I like to think of it is a observable and a subscriber. They're kind of like, it's like a localized event bus. One of the problems that we run into with event buses is that as they get bigger and they kind of cross the boundaries of your app, it becomes really hard to trace where events are coming from, what events are like ordered in a certain way. So like there's a lot of weird hidden temporal dependencies when you use an event bus. This, with Rx, it's because you're kind of composing the data you need just in time by using all of these different methods. It makes it a bit safer and more clear-cut to use. So if you want to know more about reactive programming, reactivex.io is the main hub that's been it's been collecting all of the other GitHub projects for different languages. It's got the intro and the manifesto and a lot of the documents. The one problem is a lot of these documents, they're written like very polyglot. So if you're not really comfortable, like, oh, now my example's in Java, now my example's in list. Oh my God, that's so many parentheses. Like, it becomes really difficult, like, if you're not just like sight reading the language that they decide to do the example in. A really good series of blog posts called Grokking Reactive. I put the link on it there. That makes everything a bit more simpler, and it gives everything in the, Java 8 syntax. The Netflix Stream Talk is about an hour, and it goes into more advanced concepts, how they use streaming, they basically like subscribe to Docker instances. They subscribe to, services, physical machines, and it's crazy how much work they do in the streaming environment. But very cool stuff. And finally, I try to pay attention to a lot of the concrete implementation here that I think a lot of people can immediately use if they have access to the libraries. But if you want to sort of see it from like the 10,000 foot view, there's a Coursera course on reactive programming. It's in Scala, but it also kind of talks about, you know, building a reactive system from scratch and like really paying attention to what it's trying to achieve as a programming paradigm. And then the same goes for reactivemanifesto.org. It talks about reactive systems and all of like the traits they have, like scalability, reliability, basically what you're trying to accomplish when you program in this way. So that's it for me. I have one plug, and that is for my Android competency group. If you're interested in picking up Android or picking up Reactive, or let's do IoT, because I like playing with Arduinos a whole lot, and they play nice with Android. Please feel free to reach out to me on HipChat. We're looking for project ideas. We're looking for more experienced Android people. We're looking for people who want more experience. And also we just want to find like the best resources out there to kind of bootstrap people into Android Slalom.
When are those meetings?
I just want to get a feeler out. So I've been selfishly hoarding the group to charter because before recently, it's most of the Android people at Slalom Chicago were on my charter project. That's not the case anymore, so I really just want to do a head count of anybody else who's interested. Once I get a good head count, I'm just going to start throwing stuff up on the calendar and see what sticks via consensus. And does anybody have any questions?
What's the lowest version of Java that RxJava works?
1.6, I want to say. I think there's some hacks people have done to get it even lower, but I think out of the box 1.6 is the lowest, maybe 1.4.
And if you had to choose between using RxJava in your app, but let's say you're on like 1.7 or updating to 1.8, is there one you prefer over the other?
So you can use 1.8 with Rx. It's actually preferred. And on Android, there's actually a project called RetroLambda. RetroLambda lets you code in 1.8. So it gives you lambdas. It gives you everything that 1.8 has except the new APIs, but it gives you all of the syntax helpers and all of the fluid lambda style. And then it compiles it down to 1.7. So that is probably the most preferred for Android. But if you're working in, so Netflix was saying their servers, they run a lot of their instances on 1.8, and they use Reactive with 1.8 just fine. Cool, well that's all I got. Thanks for listening.
Awesome, great presentation. You want to